Hi, all, welcome back. And today we are going to learn about relational algebra, which is a very important topic in SQL queries section. So, before jumping onto the SQL queries, we need to learn about relational algebra because here we talk about different kind of relational algebra expressions and different operations onto that. So, first of all, what is a relational algebra? So this is RA expressions, okay, RA expressions, okay, which results into distinct tuple, which results into distinct tuples. Okay, so to understand the relational algebra, we need to first look into the basic operators. So, what are the basic operators we use over the relations? So, first of all, we will learn about the basic operators. So, the very first operator is projection. Okay, we'll talk about each of them in detail, but first let's learn what are the basic operation. Let's call them operator. Okay, so the basic operators. Mm-mm. Operators. So the first one is projection. Then we have something called, we write like this, and this is called selection. Then we have something called cross product. Okay. And after that, we have something called union. Then we have minus, or also known as set difference. Okay. And finally, we have something called row, which is known as a rename operator. So all these projection, selection, cross, union, minus, and row are called the basic relational operators because they are basic. Now, what does that mean? So we'll learn about this next when we talk of derived operator. So derived operator are something which are derived from the basic operators. Okay, so basic operators are definitely not derived operator, they are basic, and that's why the term came derived, because these derived operator have been derived from the basic operator. So for example, this is intersection is a derived operator, right? So how is intersection derived? So it is derived from minus. So minus is basically a basic operator, and intersection is a derived operator which is derived from the basic operator minus. Okay. Next we have called join. Now this join will include all the internal external join, and it is derived from cross, it is derived from selection, and it is derived from projection. So all these are basic operator. So join is a derived operator because it has been derived from these three basic operators. Okay. This includes all type of joins we will see next, and then we have the division operator. So this division operator has also been derived from the basic operators like projection, selection, cross product, okay, and minus. We should subtract this part. So this is not there, so it is just cross product. It is just a projection, then it is cross product, and it is minus. Okay, so division is also a derived operator. And as I have said, so we have joins. So right external join, left external joins, and definitely we have this outer join like that. So all these have been derived from uh, these basic operators. Okay, and union and minus and all. So these are derived operators. Okay, so in this way we can categorize the derived operators and the basic operators. Sorry, for join, just a second. It has yeah, it's fine. Okay, so yeah, so this is the basic difference between derived operators and basic operators. Now how to see, for example, we have two relations like r and s. So this is a derived operator. So to write it in other way, we can write r minus r minus s. So we are removing something from r. So whatever there is in s, okay, this includes only records of r, and we are subtracting from r. This contain all the records of r. So we are subtracting from all the records of r only the records of r. So whatever there will be records of r and s. Okay, so this way we write it like this. So definitely it is this derived operator, intersection operator, has been derived from basic operator, that is minus. Okay, so this way, in order to just understand it more clearly, so we have this r and we have this s, and to find out this intersection of r and s, we can write r minus r in minus s. So whatever there is, let me change the pen color. So so whatever there is in r and not in s, that is this part that we are subtracting from r. So this is what is here, r minus s, whatever in r but not in s. So we are subtracting from this entire r, this part. So whatever we are getting is the what. So this includes the entire r. So whatever here we are getting is this part. Okay, so this is about intersection operator. uh, so let's begin with the basic operator. So first, basic operator is the projection. Okay, so in projection, what we use, so if we are projecting from r, so we need to provide which attribute we are projecting. So this will give us used to project the specified attribute, the specified attribute from R. Okay, so this projection operator will work to project the specified attribute from R. Then we have something called selection operator. So this is selection operator. So this is used to select the records from R, the records from R that satisfy the condition predicate P. Okay, so that satisfies the condition P. We'll see what these two are in an example. Just I'm showing you. So let's say we have a relation R. Okay, so we have this relational table, and here is this relation named as R, and we have three columns A, B, C, and for each of them we have values like 2, 3, 7, 4, and 4, and for B we have values like 4, 4, 3, 3, and then 3, and for C we have column like 6, 6, 5, 6, and 6, right? So these are the corresponding values in each row. Okay, now if somebody asks, so and please note one point. Okay, let's talk about first this. So if we are applying the projection operator, and we are choosing the attribute b and c. Okay, so these are the attributes, a, b, and c are the attributes of the relation r. right? So if we are projecting B and C over R, okay, so this will yield into B, C, and we will get the values of B and C. So it is 4, 6, and 3, 5, and 3, 6. Please note that we have these occurring twice, okay, but in the result of this, we have this single times. So that means result of queries don't lead to duplicate records, don't lead to duplicate records. Okay, so we are not getting duplicate records for these kind of queries. Okay, so this is a very important point to note in terms of relational algebra. Okay, similarly for the same relation, so this is about projection operator. Similarly for the same relation, let's redraw this relation again, and this is relation R, and these are the attributes A, B, C, and we have the values for each row like 2, 4, 6, 3, 4, 6, 7, 3, 5, 7, 3, 6, and then 4, 3, 6, and then we are applying a selection operator on relation R with the predicate condition that A has to be greater than or equal to 4. Then this will yield into a result which will contain ABC, but only values of A which is greater than or equal to 4. So these value will be segregated out. So it will yield into these records 736 and 436. So for each of these, we have the A value greater than equal to 4. So these values will be segregated out from there. Do we have anything common here? 7, 3. Okay, it's different, right? So this is the result of this query, right? Similarly, if we write something like if we are using both in common, usually we are using the projection and selection operator in combination. Okay, so if we say we have a relation of student, and we are selecting all those students whose age is greater than 20. So this is what is selection operator. So we are choosing all those students whose age is greater than 20, and then we are projecting their SIDs. So let's say student has a table and it contains SID and age. So for each SID we have corresponding age. So this query will result into SIDs, okay, SIDs of all those students whose age is greater than 20, whose age is greater than 20. Okay, so this will yield into this part. So it will yield the SIDs of all the students whose age is greater than 20. So you have to interpret from this RA expression what it is talking of. Okay, and correspondingly, if you have the relation, you have to find out the value for that. Okay, now let's see the another operator which is the most commonly used operator, and that is cross product. So it is also a basic relational operator. Okay, so what does this cross product means? So if we have two relation R and S, then cross product onto these relation results into all the attributes of A followed by all the attributes of S. Okay, so for result of all the attributes, sorry, R, all the attributes of R followed by all the attributes of S. So R cross S results into all the attributes of R followed by all the attributes of S. So this is this. Okay. Now what or we can write it in other way. This can be expressed as each record of R. Okay, this is very important. Each record of R pairs with pairs with each record of S. Yeah, every record of S. Now, how does it happen? We'll see via an example. Okay, so let's say we have a relation R, and for this relation we have three attributes A, B, C, and it is 2, 4, 5. Then we have 3, 4, 7. Then we have 7, 3, 5. Okay, so this is R, and then we have another relation that is S, and it has attribute C and D, and the values are 5, 6, and 4, 5. Note that this is the common attribute for each of them. Okay, this might be the common attribute or may not be. Okay, so these are the x field, and these are the y field. Okay, so these are n distinct tuples. Okay, I'm so sorry, it is tuple, not couple. And these are m distinct tuples. Okay, please note it is tuple, not couple. Okay, right. So now if we have to form a relation with cross product of R and S, then what we will do in first go, see, there is a difference between join and cross product. So even though you might misinterpret that C is both common, so let us consider it for now C1 and C2. Okay, so or we can take it as C of R and C of S. Okay, so if we are doing this cross product, then it will yield into A, B, C, C, D. So this C correspond to this, and this C corresponds to this. Right, now we'll make the cross product. So here, okay, let's make the cross product. So each product will pair up with each product of each tuple will pair up with each tuple of S. Right, so it will be 2, 4, 5, 5, 6, 2, 4, 5, 4, 5, 3, 4, 7, 5, 6, 3, 4, 7, 4, 5, and then we have 7, 3, 5, 5, 6, and 7, 3, 5, 4, 5. Okay, so all together we have, if this is n tuple, this is m tuple, then n cross m tuples. Okay, in R cross S, and the number of attribute also is gonna change. Right, when we will learn about join, then we will talk about this common attribute. But for now, if we are doing the cross product of R and S, then the total number of attribute in R cross S will be n plus sorry, what is this? X and Y, right? So it is uh, um, so it will be X plus Y, because X is, this is, oh, what is happening? Okay, so this is X and this is Y. So total number of attributes is x plus y. Please note, number of field will be the addition of the two fields, and product will be the multiplication of the number of tuples. Okay, there are some edge cases that we need to know. For example, A has 2, 4, and B has a tuple like empty. So B is empty. Then if we cross product with A and B, then which is empty. Okay, so this is an important thing to note. Right, now there is one more thing, that R cross S results R cross S results non-empty record non-empty record set only if R and S must be non-empty. RNS must be non-empty record set. Okay. So both has to be non-empty. This has to be non-empty and this too has to be non-empty. So please note in mind, if either one is empty, then we get an empty set of record set. Okay. Next we will learn about join and conditional joins. Different types of joins are there, so that we are going to learn. And of course after that we will learn about the set operations, and lastly we will learn about divisions. But before that, I would like to ensure you that if this is very important part, right? So if you are known of, because this we will be using in further operations, so please note that if either one, for this has to be non-empty set, both has to be non-empty. And please keep this example in mind, that if we have in R tuples like 2 and 4, and if we have in S as empty, then R cross S will be empty. Okay, this is very important to note. Okay, and the next thing is, if we want to compare, if we want to compare R data with S data, our data with S data, we need to apply predicate condition over cross multiplication. Okay, we need to apply predicate condition after cross product, after cross product of RNS. This is very important. Okay, so whenever you have to find out any specific tuple from RNS, and you have to compare the data of R data with S data, then you can apply predicate condition after the cross product of RNS. Okay, so this is important part. Keeping this in mind, we are gonna close this video right now, and we will be learning more about um, join operator, that is a derived operator, and the different types of join operator in the next video. Meanwhile, if you do have any questions or any comment, then please do let me know in the comment section. And that's all for this video. Keep watching. Thank you very much.